Hi everyone, good afternoon, and a very warm welcome to all of you. Thank you for joining us today for the Masterclass Engineering for Business Resilience and Sustainable Impact by the University of Warwick. This is Ishanka Huja. I'm the Client Engagement Specialist at Study In, and I will be moderating today's session. At Study In, we work closely with the leading global universities, including the University of Warwick, to help students gain clarity about international study opportunities and make informed academic and career decisions. Today's masterclass is designed for students interested in understanding how sustainability, engineering, and digital innovation are shaping the future of business. Over the next 1 hour, we will explore how system thinking, design engineering, and innovative approaches are helping organizations building resilience and responding effectively to global challenges across the industries. It is now my pleasure to introduce our speaker for today, Nick Goldsby. He's the associate professor in design engineering at Warwick Manufacturing Group at the University of Warwick. Nick leads design teaching at WMG and specializes in sustainable design, digital workflows, and engineering for commercial impact. He is also the course director for MSc Engineering Design Management and Master's Design for Sustainability and contributes across programs in engineering, business management, innovation, entrepreneurship, and management. Along with Nick, Kathy has also joined. A warm welcome to her. Before we begin, a quick note for everyone. We have a Q&A option at the end. So Q&A option is available at the bottom of your screen. Please feel free to submit your questions and we will address them at the end of the session. Now, without any further delay, I would hand over to Nick. Looking forward to you. Nick, over to you.
Thank you so much for that fantastic introduction. I'll just share my screen. Fantastic. You should be able to see everything now. Go. Can you see?
Yes, we can see.
Fantastic. Good. So I'll begin. So, of course, a warm welcome from WMG and the University of Warwick. Of course, you'll be with me today to, of course, go for this Engineering for Business Resilience and Sustainable Impact Masterclass. Of course, from that fantastic introduction, I'll just add to say just a few bits of extra detail of myself, as Associate Professor in Design Engineering here at WMG. Kind of in my background, I've led, a lot of, significant, large-scale educational and industrial design projects here at the University of Warwick, at other institutes and other organisations. I've directed major engineering projects, with a multi-million-pound spend. I've led transformative projects which bridge physical and digital design workflows, to, of course, rapidly iterate through design and new product development, and done a lot of industrial consultancy across many sectors, including health, automotive, sustainability, and resilient infrastructure projects. Of course, help sort of large-scale, new, innovative technology to, of course, be ready, for large-scale manufacture and investment. And so, from my experiences, this brings us to the starting points around very much, of course, where we are today, and that being that the world is at a critical turning point, which I think we probably can all see, we can probably all feel. We can recognise that climate emergency is ever pressing, where we have rising global temperatures, we have increasingly extreme weather, we have environmental degradation, and a lot of this is accelerating at unprecedented rates, which has an impact, of course, on our daily lives, but also, of course, a lot of impact on economies and, of course, businesses. Likewise, this feeds into, of course, resource scarcity. So we have a lot of pressure on our materials. We have pressure on our fresh water reserves. Then, of course, we also have, sort of energy supplies intensifying, of course, in terms of the global demand. Of course, we look at, things around, AI data centers, whilst, of course, we have pressure on, of course, where exactly our energy is coming from. Geopolitics is ever increasing, day by day, and changing, influencing really how business, trades, our supply chains, investment confidence, cost, policy change, conflict, international relations, and of course, then down to, of course, everyone else. We feel that, of course, in our jobs, in the prices that we're paying, of course, sort of for goods, for services, in our own security, our mobility, and also, this economic uncertainty and the impact on our life. But a lot of this then also, of course, represents, opportunity for change. Likewise, we have global health concerns in terms of, say, air pollution, quality of water, our ecosystems and how we're managing those, and sort of the drivers behind major public health risks, which of course impacts, millions around the world. And, of course, in terms of, say, good directions that, of course, many, of course, different nations are trying to head in is, of course, with policy transformation. Positive policy transformation, of course, areas such as net zero, circular economy regulations, international sustainability frameworks, sort of sector level frameworks and commitments that, of course, again, present, say, what appears to be, say, challenge to different businesses, but then also, of course, likewise presents a lot of opportunity to, of course, improve and change, of course, offer something new. It gives space to innovate. And so these pressures, of course, they are not happening in isolation away from each other. These challenges, they interact, and of course, in many cases, they compound. And really, say, what we're focused on is recognizing, around engineering and business decisions, how those interact and how they, of course, impact our future, say, for not just this year, but many years to come, but also kind of how we can have the appropriate level of agility and adaptability to, of course, meet the next change, which, of course, comes to us. And so this is why we consider this idea of business resilience. And of course, what I will look at in terms of, say, actually engineering business resilience. I think an important thing to recognize here is the fact that traditionally, we have been very much in the view of prevention and or recovery. And then quite often recovery seems to be, say, the area where, of course, organizations find themselves trying to recover from these major shocks, or what seems to, of course, be unexpected. But where we are now is these shocks are becoming, say, more frequent, where organizationally, of course, we're having to, of course, make changes to try and maintain and sustain our business, sustain our systems. So where we need to be is recognizing that we need to engineer, we need to ensure that we have modern resilience designed into our business, not bolted on. And, we recognize that business resilience does not equal risk management. Risk management is valuable, and of course we need it, but that isn't what business resilience is. We need both of these. This isn't just about recovery. It's not about just efficiency. It's not even just about sustainability. It is about this ability to absorb these shocks, to adapt, and most importantly, as a business, the core thing, of course, that we do in business is we are creating value to, of course, exchange with our customers. And we, of course, ensure that we maintain that fair value exchange that's occurring. And that is, of course, what ultimately will sustain us. That is what will, of course, sustain and also support the growth of economies. That is what, of course, will provide, quality and long-term job security. It is what will, of course, create a more sustainable, environmentally friendly environment as well. And so, we're talking about performance under uncertainty, not just about stability under what we consider normal conditions. So, of course, we've recognized these areas around, climate, resources, geopolitics, health, policy transformation. And really, this is where, this increasing complexity, this is what is driving this demand for actually having resilience designed in. And so resilience is no longer, like we said, risk management or contingency planning. It is going beyond this, and it is designing systems. And this is the idea of, say, this systemic view and the systemic design of course, how we are, of course, doing business so that we can continue to perform under pressure and we can continue to evolve over time whilst we're absorbing those shocks. And so, of course, fundamentally, sustainability and resilience are tightly coupled together. And of course, if we are ensuring, of course, resilience whilst engaging with, of course, our areas around, say, circular economy, meeting, of course, environmental demand, improving ecosystems, that resilience ensures our sustainable impact. And so resilience is now a strategic capability. And this is something that, of course, we need to recognize, and we need to, of course, design in. We need to engineer this in. And so this kind of brings us to, of course, recognizing, well, really, in terms of organizational priorities, organizations do not lack ambition, but of course, the challenge that they face is managing a number of competing priorities and, managing these simultaneously, such as stability and flexibility. So organizations need stability. They need to have predictable quality. They need to have reliable delivery. They need to have trusted operations. But at the same time, they need to adjust to these shocks, to this regulation change, to supply chain disruption or market changes, consumer behavior changes. And so we need to recognize that engineering decisions, they determine where that balance sits. And that will bring us to product design, process configuration, overall system architecture. In terms of our sustainable performance can no longer just be measured only in, financial or short-term financial benefits. Sustainable performance asks, are we protecting long-term value? Are we increasing our exposure to future risk? Are today's gains creating tomorrow's constraints so we can no longer perform? So this is where sustainability becomes a strategic concern, not just a reporting exercise. And so quite often we've, of course, seen many organizations, reporting their corporate social responsibility, kind of recognizing, key metrics to go, this year we've performed this well in these areas. But we have to move beyond this and recognize that, of course, what we may take today may, of course, remove it to be taken tomorrow. And this is where we, of course, have to manage our system more sensitively to ensure the long-term resilience and therefore sustainability of our business, of our economies. Circularity and resource security. So many organizations are now waking up to the risk that is embedded in what we'd call, say, linear systems. And so if I talk about a linear system, we talk about the traditional approach to business where it's take, make, waste. We take resources from our planets. We, of course, add value to those resources by, of course, manufacturing something. And then we hand those over to our customers, and then they have to, of course, dispose of them, however. And then all of that waste is gone, okay? We need to move to circular approaches so it reduces our dependency on volatile materials. It improves our resource certainty. Of course, we know that that resource we need will continue to build there. And then, of course, that will build in resilience into our sourcing and therefore, of course, our production. So circularity is not just about environmental impact, it's about operational and strategic security long-term. Was digital transformation. This is, of course, essential for visibility and speed, but of course, it also does introduce new risks. So as leaders, we must balance, automation and AI with human judgment, data availability with decision quality. The integrity of that system complexity needs to be managed. And so whilst digital systems and AI are powerful enablers of resilience, we have to carefully consider how we build them into our underlying systems to ensure that long-term performance. And then, of course, fundamentally, of course, there is no economy, there is no business, there's no commercial venture without a skilled workforce. And of course, this becomes a particular area where an organization has to very carefully manage that talent which is available to them and of course, which they secure. And so skills shortages are now a structural constraint to, of course, how you wish to, of course, innovate, how you wish to, of course, make your business grow. So organizations increasingly need people who can work across disciplines. They can understand systems very much like we're talking now. We're recognizing greater system complexity that we need to bring together and we need to gain insight across. And so organizations need talent which can work across these disciplines. They can think systemically rather than work purely in silos. They need to be able to connect technical detail with business objectives, which if I jump ahead, that is where WMG is leading. So this is much about mindset as it is about technical skill set. And so what's clear is that these priorities cannot be optimized independently. They interact, they reinforce each other. And sometimes they can conflict, but of course, this is where, of course, we have to, of course, make these decisions with, of course, the data quality we have available to us. So this is exactly why resilience must be approached very much as an engineering and a systems problem. It isn't about just a strategic aspiration. So what is engineering for business resilience and sustainable impact? And so I think really at this point, we've probably recognized quite well pretty much what we do mean by, of course, business resilience. And I think we're probably all very aware of what we mean by sustainable impact. And therefore the fact that, of course, we are, of course, actually having, say, some improvement. So sustainable impact typically is recognizing, of course, that we are possibly reducing, say, the carbon intensity or, of course, our waste management, of course, whether, of course, we're, of course, putting, of course, noxious gases into the environment or, of course, damaging water and ecosystems. But it, of course, goes beyond, of course, to say environmental impact. And we do recognize, say, social impact. So therefore, there is that side of the fact of, of course, we providing, say, quality of life. And that can be through, good job security, good pay, good, of course, systemic opportunities for society, as well as, of course, an economy which is functioning, an economy, of course, which is growing. And so just of course, reinforce that, of course, in sustainable impact, we are looking at impact across what we recognize as the triple bottom line. So we are looking at environment, we are looking at society, we are looking at economy. And so where we, of course, recognize where resilience comes into play here directly with sustainable impact is the fact that, of course, we need our systems, we need our economies, our societies, our businesses to be resilient over time. So, of course, they can sustain excellence over time to actually have sustained impact rather than, of course, potentially having, say, something which, of course, is a innovative new venture, but then it gets stifled or, of course, it fails because it isn't able to absorb these shocks, this volatility, this uncertainty that, of course, we seem to be more and more exposed to sort of more rapidly than I think we felt, say, just a few years ago. So engineering resilience is not just about stronger individual components within our business. It's about how our products, our services, our supply chains, and our organizations are fundamentally designed as a system. And so this brings us to this approach of resilience must be engineered deliberately. So therefore, we have to actually very consciously engineer and take this engineering approach to actual, say, business design and key business decisions, which is ultimately embedded in the engineering practice of an organization. So when we talk about business resilience, we often frame it as a management or a leadership problem. And so something which is, very top of the organization and, will filter down. But the actual reality is that resilience is largely determined by engineering and design decisions, very much so, which of course interact, of course, with various different business functions. And many of these decisions may have been made years earlier, but we still need to understand these, because we need to understand our susceptibility to cause these shocks which will occur. So if we say focus just on products, so product architecture, so the overall kind of configuration, what is within it, the materials, how things interact, how it's been manufactured, how it's going to say where the material is going to come from, how it will move around, how it will be used, how it will be disposed of. So this product architecture determines resilience more than most people would realize. And we have to recognize, the strength in aspects such as modular design, our material choices, our overall life cycle performance of that particular product or our product portfolio. All of these influence how easily products can be adapted when we do see regulatory change, when we do start to see materials becoming more scarce and therefore, of course, suddenly skyrockets in price, when we do see market shifts, where we see, of course, major competition within our sector or sector disruption, or like I said before, consumer behavior change. Where we currently typically are is the fact that we have highly optimized products, highly optimized systems, and they're tightly integrated into those products, and they therefore perform well. But then the problem becomes when change happens. And because we have that optimization under certain conditions, when the change occurs, that's, of course, when we have such big problems. So when we come to, of course, that next interaction, we consider processes as kind of this secondary point. So manufacturing and operational processes are typically optimized for cost, and they're optimized for efficiency. But likewise, when we have that optimization to be so efficient under today's conditions, that removes our flexibility. And this is where, of course, like I've already said, if we have no flexibility because we're so optimized for what is our ideal situation of today, that's where we are not resilient when, of course, variation occurs. We can't absorb that variation if there is, for instance, a change which is going to change fundamentally how we're going to manufacture things. And so, we're working in volume with materials, with certain configurations, but we need to break that down. And we need to recognize that we need to actually design in a balance between efficiency and adaptability. And that is a major engineering challenge. But this is where, of course, there's significant opportunity with, say, of course, varying points of, say, manufacturing technology, the use of course, different sort of systems in automation, and then, of course, robotics, and then, of course, that integration, of course, with AI and digital systems. So there's many, say, opportunities to, of course, introduce that adaptability, that data insight to help us have that flexibility whilst we're still optimizing processes. Of course, supply chains, they're perhaps the most visible source of fragility that we all do see today, and probably have been seeing, I would say, very, very vividly, very clearly for the past 5 years. So what we have an issue with is when you have single source dependencies, where you have long linear supply chains, where you have limited transparency, and all of that stems from the design decisions that have created that network structure, that sourcing strategy. And so fundamentally, these design and engineering decisions, which have been made, early on, say, possibly in a product or business development process, in the hands, say, of the designers and the engineers, that has determined fundamentally where you will be able to go to actually, of course, source the materials, the sub-assemblies, the products you need for your business to function. It creates the supply chain network that, of course, all of the things, the lifeline that your business survives on, how that's constructed. And that needs to be understood very early on. And so engineering for resilience in our supply chains means not only just understanding the system as a whole, understanding it as a whole rather than just recognizing our individual suppliers. And so it's not just, again, about designing for efficiency, we're designing for optionality. So there, of course, we are not tied to a singular design network, singular suppliers in singular locations. So designing for optionality is very, very important. And so our fourth key area we can recognize to engineer for resilience is AI and digital systems. And so digital systems, of course, and AI, they determine how quickly, in, of course, the era we're in now, how quickly we can sense, respond, and adapt to these changes. So digital workflows, data integration, simulation tools, they do not just improve, say, efficiency within our business, they now enable foresight. They enable us to kind of actually start to see these signals of, say, this disruption coming. If you can't see what's happening in your system, you cannot manage resilience. And so when we bring AI into this, AI builds on, our digital data capabilities, our digital systems, because it is able to allow us to have, say, much stronger pattern detection across much greater complexity within our systems to help us with prediction of disruptions rather than simply waiting to then react. So we become faster and better informed as decision makers when we are heading into uncertainty. So when we say resilience is engineered, what we really mean is that within our products, our processes, our supply chains, and our digital systems, we quietly encode this resilience into the organization, into the business itself. And so this is why sustainability, systems thinking, digital innovation, they're not separate agendas. They're not discrete areas that we think we can recognize we have talent in. Together, they define how resilient an organization can actually be. So we recognize that most sources of our fragility, they are fundamentally engineered decisions, material choices, system architecture, digital dependencies, our sourcing strategies. Therefore, resilience must be addressed upstream through the organization, and it must be a consideration for design and for recognizing, of course, the overall system that we've created as a business and the overall system that we operate in, of course, in terms of, say, our local society, our broad society, our environment, the global stage. So I kind of, I've picked on this point already quite a bit, but I find it really, say, quite important because we recognize that there's so much that we are trying to balance as professionals, as businesses. So every business is trying to balance these points around efficiency against flexibility, cost against what is viewed as sustainability as a cost factor, optimization against adaptability. But many, many failures, they come from over-optimization. They come from having very, very lean systems, which often become the most fragile systems. So sustainable and circular approaches, they often actually increase our flexibility and therefore, of course, our resilience. But one of the reasons resilience is so challenging is that it's not just about maximizing a single outcome. Like if we take the typical linear systems of take, make, waste, we can maximize the fact that, of course, we are, of course, reducing manufacturing cost. And then, we've got very clear, strong, singular outcomes that we're focusing on to, of course, maximize profits. But for resilience, we're managing these tensions. And these tensions, of course, are fundamentally engineering decisions in terms of, how we, of course, can be efficient against flexibility, how we can manage cost against sustainable change, how we can, of course, actually optimize against, of course, being adaptable. So over the past few decades, organizations have rightly pursued efficiency in lean manufacturing, in just-in-time supply chains. They've highly optimized those processes, which in many cases, that efficiency has often removed buffers from redundancy and therefore optionality. It has often, of course, reduced price and therefore, getting away many, democratized access to so many goods and services. But like I say, it's removed the redundancy in the system to absorb the shock. So from an engineering perspective, resilience requires us to ask, where do we need to have flexibility? Where is the redundant strategic capability against managing the waste? What is the most fragile point of our system against the most efficient points? Likewise, with cost against sustainability, sustainability is sometimes framed as a cost, which we're kind of, suffering. But this is a very, very narrow and short-term view. Sustainable design, circular materials, energy efficiency, reduced dependency on scarce resources, that reduces your long-term risk and exposure. So taking engineering decisions to minimize upfront cost can lock organizations into fragile supply chains. So because we definitely want to, of course, over-optimize to, of course, reduce cost today, we may be locked into fragility tomorrow, and therefore we expose ourselves to volatility and regulatory risk. So resilience emerges when sustainability is treated as a value protection strategy over time, rather than viewing sustainability as a compliance exercise. Then finally, optimization via adaptability. Optimization assumes stable conditions. It assumes that today's environment is going to be tomorrow's environment, but that is anything but stable. Highly optimized products, processes, and digital systems perform well when you have a very narrow set of conditions. Engineering for adaptability is where you design more modular systems, reconfigure all processes, architecture which can evolve over time, and that can reduce your exposure to, of course, these shocks that we're discussing. So engineering business resilience is not about choosing the right side of these tensions. It's not about saying we've got to move away from being efficient and we've got to be flexible. We've got to, of course, not manage cost and, of course, just make sure we're sustainable. It's not about the fact that we've got to stop optimizing and we've got to, of course, make sure everything is adaptable. It's about actually, balancing, intentionally managing these tensions. And that balance, that's achieved through systemic thinking. It's achieved through sustainable design practices. It's achieved through digitally enabled decision making, not through one alone. So to make resilience more actionable in terms of how we really go about doing it, now we recognize these various areas that we are actually trying to interact with, we can think of it in layers. And so business resilience is not one thing. It's built across three distinct but connected levels or layers: operational resilience, structural resilience, and strategic resilience. And so operational resilience, that is about keeping the system running. That is about what most people recognize immediately in, of course, our day-to-day operations. But it's critical, but it's also, it can be reactive. So operational resilience helps you survive shocks, but it does not necessarily help you adapt to a changing world. So, of course, we are recognizing that, of course, we still have our processes, we have our data, we have our digital uptime, of course, which is important now in our digital age. But we, of course, are maintaining our process reliability. We are contingency planning. Structural resilience is fundamentally how the system is designed. So structural resilience is where engineering really comes into play massively. The design choices define how easily the system can be reconfigured, how exposed it is to single points of failure, how dependent it is on particular scarce resources or fragile relationships. So structural resilience is designed in often years before a disruption will occur. So we start to recognize that susceptibility in our product architecture, how we set up our processes, what that supply chain network is, and disruption that can occur to it, and how we have integrated, our digital systems effectively together. Strategic resilience is the ability to change direction. So strategic resilience is typically the least visible but most powerful layer in our business. And it reflects an organization's ability to pivot its business model. So that aspect of how a business actually is creating and exchanging value. It reflects an organization's approach to this. So it is about innovation. It is about sustainability. It is about skills and capabilities within the workforce. And that determines how well you can respond to long-term shifts such as regulation, climate, or major technology disruption, like we are seeing, of course, with the rapid inclusion of AI into our systems, our products, our business, our day-to-day lives. So this layer on strategic resilience depends heavily on leadership mindsets, on the investment in skills, in the investment in capability, and in the integration of sustainability into strategy. Typically, most organizations invest in operational fixes, which fundamentally, of course, is that operational resilience. But they underinvest or they fail to recognize structural and strategic resilience. But to engineer for business resilience, it means working across all three of these layers simultaneously and connecting them. So sustainability strengthens structural and strategic resilience, while digital systems and AI enhance sensing, coordination, and decision-making across all layers. So whilst we, of course, looked at these layers relatively independently, and of course, I'm recognizing, of course, we've got to work with them simultaneously, the critical question is, how do organizations actually move between these layers in practice? So from operational to structural, when organizations face disruption, the first instinct is often to add control, more contingency plans, more reporting, more firefighting. But movement from operational to structural resilience happens when organizations step back and they ask, why did this fail? What design decisions created this fragility? That leads to changes in our product architecture, our processes, our supply chains, our digital systems. And this is where engineering judgment matters most. So we're at the point where we are being more diagnostic, and we are therefore starting to redesign these systems so, of course, we can be preemptive. From structural to strategic resilience, structural resilience improves stability, but strategic resilience enables change. So movement here requires investment in transferable skills, our innovation capability, our sustainable technology, and our flexible business models. And so this is crucial in reducing our long-term dependency on various, of course, particular shocks. So we are building in that optionality, so we do have future choices. We aren't locked in to, of course, what we have today. But that investment in capability is very, very important to enable this. And so to enable across all layers, it requires these key capabilities I keep mentioning: systems thinking, sustainable design. So systems thinking allows you to understand interactions and the trade-offs that may occur. Sustainable design allows you to reduce risk and increase adaptability. And of course, digital systems and AI capability allows you to, of course, be able to, of course, sense these changes, model scenarios, be predictive, and support faster decision-making at critical points. This is why resilience is fundamentally an engineering and design challenge and not just, say, a leadership one. So a simple question, kind of a reflective point that, I would task anyone, of course, at any point in their professional career, or the sector they work in or an organization they work in, is to just ask that point of, can your organization change what it does, how it does it, and who it depends on without starting again? What this single question reveals is that resilience maturity within the business. If the answer is no, the issue is usually rigid design, linear supply chains, skill gaps, and poor digital integration. And this is exactly where engineering-led critical thinking becomes critical. And so this brings us to really, say, the resilience skill set. And all these points, of course, that I've been mentioning very, very much throughout the entire workshop here is the fact of, as an individual, as a professional, you need to have this systems thinking capability. You need to be able to, of course, work with sustainable design and understand what that means. You need to be able to integrate business and technology together. You need to be able to, of course, be very digitally fluent and therefore able to, of course, be a key decision maker with, say, vast amounts of, say, data that you can manage, which, of course, then feeds into AI augmentation. And so very much, of course, being, say, a professional who is augmented by AI is becoming, say, of course, a critical point, say, for businesses. So it's not about the fact that, of course, you are an AI expert, but it's the fact that you are able to use AI to augment the capabilities that you possess so you can, of course, be more effective. You can bring different areas, integration, bring insights, and you can do that faster than, of course, we have been doing it previously. So you can respond quicker, and also you can bring in this foresight. So resilience is a capability. Capabilities are learned, and learning must be applied. These are hybrid skills, and they're rarely developed in single discipline programs. And you can see this in the growing demand for what we'd recognize as kind of more interdisciplinary capable professionals. And that's what is reflected in postgraduate education at WMG. So WMG is very much this bridge to, of course, having these various capabilities which organizations require. So WMG values not just context, but how these capabilities are developed in practice, that application, so actually really possess the capability. And so here at WMG, we are pioneers in academic and industrial collaboration since our foundation in 1980. We're renowned for that industry relevant education and research impacts, which goes on with, of course, hundreds of industrial partners, because we're so embedded with industry that at points we're driving industry forward, but then also, of course, we are driving forward with industry. We're a multidisciplinary department. So, of course, we have all this various capability, which is then embedded within our master's courses across applied management, digital business, data science, machine intelligence, healthcare, design, innovation, and sustainability and automotive technology. We are an incredibly diverse group here in WMG with over 1,400 students from 62 countries. We've got a vast amount of, say, expertise and talent with our 900 plus staff across our many incredible buildings, which have great facilities. And WMG's applied research continues to contribute approximately 40% of what the University of Warwick's, world-leading research income actually is. So we are, say, core to the University of Warwick's research centre. Of course, many of you may be very aware of the various different courses, of course, that we do have available at postgraduate level across applied management and industrial engineering, digital business and innovation, and digital technologies and engineering. So from engineering business management, project management, supply chain logistics, of course, engineering design and sustainability with myself, international trade, innovation entrepreneurship, e-business management with various different, say, specialist streams, of course, applied artificial intelligence, cyber security, games engineering, and of course, courses in, automotive and autonomous vehicles, as well as renewable energy. And so, there's a vast area, of course, of fundamentally, of course, business connected to engineering, digital, AI. And of course, we connect across these courses and we have a very vibrant expert community of students and staff. We are this bridge between these different areas, which fundamentally is ensuring the future of resilient businesses and economies going forward. So we provide future-ready skills. You learn methods and tools grounded in how modern organizations are currently transforming to be sustainable. We give you hands-on experience. You solve real problems sourced from industrial challenges and research projects. We enhance your employability as we bridge engineering, design, sustainability, management, digital, AI. These are highly valued combinations. And of course, we have an incredibly powerful reputation for applied innovation across our MSc programs, which are recognized worldwide. There's various, of course, other further benefits and interactions, of course, at being at the University of Warwick with us. We have, different, skills awards through WMG Skills Plus and the Warwick Award. We have, of course, careers guidance. We have, of course, various careers fairs to, of course, support with, with employability. We provide CV and interview training and also personal branding and LinkedIn workshops, just, of course, help set you up for success following, of course, graduation. But, of course, very much our students and therefore becoming graduates, they remain a very much part of, the WMG community once they've graduated. And we, of course, often continue to hear from them and hear their successes going forward. So, of course, this slide is just here, just, of course, give you, key details, but I won't exhaustively go through it. But, of course, if you kind of are interested in WMG courses, of course, you can go to, of course, warwick.ac.uk and find WMG Masters programs. And of course, here, of course, to key points and our entry requirements. And of course, what is required to, of course, make an application in terms of references and a statement of purpose. But at this point, this is where, of course, I will stop talking and myself and Kathy will be able to, of course, take any questions. So thank you for your attention. It's been an absolute pleasure. I'll just stop.
Many thanks, Nick, for conducting such an informative session. I'm confident it was extremely helpful for all the prospective students who have joined. Thank you once again, and it's time for the Q&A. Right. Let me check. How does the program combine engineering skills with business strategy and sustainability to solve real-world problems?
Sorry, repeat the question again.
Yes. How does the program combine engineering skills with business strategy and sustainability to solve real-world problems?
So this is where, of course, we very carefully do consider where kind of what the key different, knowledge bases, the key capabilities, the key practices are across, a particular, study or focus. And so it's about, of course, having a program which provides those initial bases, but then, of course, across the program, we do recognize, of course, how they interact and how they intersect. So we can sort of, connect these different areas together. And one thing we do very well at WMG is we bring in, of course, a lot of industrial insights. We bring in, a lot of, industrial speakers. And so we're then able to provide very, very vivid, very clear examples, real world examples of where you actually, of course, can see where there's potentially been, say, failures or issues or successes or good practice. And so we are able to, of course, expose students direct, of course, what's happened in industry, what's happening in industry, and then, of course, where this direct knowledge base, these practices connect together and how they're executed. And likewise, as well, of course, through, of course, providing, say, industry relevant or industry live case studies or problem bases, we give students the time to actually, of course, apply their learning. So it isn't just about, of course, what we'd sometimes call, the sage on the stage, where you're just listening to, your professor, your instructor. We make sure we bring, say, the time in, we bring, say, assignments in, where students actually practice fundamentally, of course, what we're preaching. So they, of course, can then have an exposure themselves, and of course, with feedback where things go wrong, they learn, of course, in those points. So we make sure that whilst we do have these different areas, we connect them together across.
Thank you. One more question from Nancy. Also wanted to ask, how does the university support students in terms of ROI through placements, networking, and career services? Kathy has already replied to that. Thank you so much, Kathy. The next one
Is
is
it worth
according to
reading?
the
Sorry, is it worth reading that answer out?
yes, of course. Within the Warwick Manufacturing Group department, we work closely with a huge number of companies through our education and research. So there is a lot of opportunity for networking. We have industry experts involved in the teaching. Employability is embedded throughout the program. We have a very proactive careers teams within the department as well as the university career services. We are one of the top universities in the country for employability. Number five, I believe, and there are opportunities for industry collaboration projects as your capstone project. This is what Kathy has replied. The
Fantastic,
next
brilliant.
question, yes, the next question is according to the chart, which two layers of engineering business resilience determine an organization's long-term resilience?
Sorry, can you repeat the question? Sorry.
According to the chart, which two layers of engineering business resilience determine an organization's long-term resilience?
I think the big thing here is recognizing that it's not about all of these things are present, and this is where the systemic or the systems thinking becomes very, very important. So whilst we have these layers, of course, in a way, of course, we're organizing and compartmentalizing, of course, where we can be actionable. But the important thing is that we don't focus singularly on individual layers unilaterally and ignore others. Because if we focus on one or two layers and neglect another, that's where, of course, our vulnerability comes in. And therefore, that's where, of course, the problem will become. And so, there could be sort of a debate, a discussion on kind of, which layer is the most impactful. But the very, very challenging thing is the fact of the shocks that, of course, we are being subjected to is becoming, say, more rapid and more variable. And so a key sort of, model you could look to is a VUCA. So the VUCA model, which recognizes aspects, of course, of volatility, uncertainty. And, we used to view these as kind of, things as black swan events, where, this was this massive shock which we weren't anticipating and suddenly appeared. And black swan events are supposed to be rare. No longer are these shocks rare. I think if you recognize since, of course, COVID in 2020, we seem to have kind of had a big, massive shock probably every 6 months that we've had to deal with. And so this is why this resilience is becoming more and more important. And we can't treat things in silos. We've got to systemically, consider and resolve these. Otherwise, if we don't, that's where we're going to be subjected to one area we feel we haven't considered or we neglected because we were so focused on, say, geopolitical issues, because that's what's happening today. Whereas there may be some massive regulatory change based on, of course, sustainability tomorrow. And so, or, a supply chain disruption here. So we shouldn't recognize one as, say, more impactful, or say one we should focus on more than another, really.
One more question. Does corporate social responsibility has any role in business resilience?
So
Hi, Kathy, can you hear me?
I can hear you. I think Nick's
Yeah, there might be
Nick's computer might
unstable.
have cut out.
Yeah.
Okay, I'm so sorry, but I'm not going to be able to answer these more technical questions
Okay,
in
no
my
worries, no
role.
worries.
But let's give Nick another couple of minutes and see if he's
Yes,
able
of course.
to
Sure, sure,
return.
sure.
But looking at the questions, I think that hopefully the majority of these have been answered from what his previous answer was
Yeah, yeah,
and through the presentation. Um, there are a couple of other good questions though, so I think maybe if we take note of those, and if Nick doesn't come back on, we can respond to those by email out to everybody.
yeah, no worries.
Are you able to take a
I
snapshot
can
of
I can take a
questions?
note of these questions, and
Mhm.
our studying staff can reach out to you in case of any queries so that you can answer them and we can pass that on to the students
Okay,
afterwards.
wonderful. Wonderful.
So
Are there, in the meantime, any questions that are not specific to the engineering, design management or resilience that I might be able to help with, more from the recruitment or the layperson's perspective, or studying at the University of Warwick? Does anybody have any questions that I may be able to answer?
as of now in the Q&A box, I can see all the questions related to engineering, business resilience,
Mhm.
employability prospects and all.
Yeah. So
No worries.
I
Yeah.
hope that it's been a really useful, informative, insightful, and interesting session
Yes, of
today.
course. Yeah.
And please do not hesitate to reach out to us. And we very much hope to welcome some of you to the University of Warwick in the near future.
Yeah, of course. Thank you so much, everyone, for joining the session. Thank you so much, Kathy, and thank you so much, Nick. I would request you to please pass on my regards to him as well. So,
Will
thank you so
do.
much, everyone, for joining the session. Wishing you all the best for the rest of the day ahead. Thank you.
Thank you. Bye bye.
Bye. Bye.